Think about how you learned what a dog is. Your parents didn't sit you down with a textbook of biological definitions. They just pointed at a golden retriever in the park and said, "Dog." After seeing enough of them, your brain figured out the pattern. For a long time, we couldn't teach computers that way. Instead, engineers had to write out exhaustive rulebooks. If you wanted a machine to do any task, you had to type out every single step in rigid, unbending code. That works for a calculator, but it falls apart for something like translating French to English or catching spam emails. There are simply too many exceptions, slang words, and weird variables for any human to write enough rules by hand. So programmers tried a different approach. Instead of writing out the rules, they started handing computers huge stacks of examples and asked the machines to figure out the rules themselves. This is the science of machine learning. It gives computers the ability to recognize patterns from data without a human needing to program every specific move. This changes the way we work with technology. We've stopped feeding computers stiff instructions and started feeding them experiences. Take the email spam filter. It's a clear example of a system that learns on the job. It starts with a massive historical stack of examples called training data. The computer is handed thousands of emails separated into two huge piles, one for known spam and another for normal, everyday messages. The computer analyzes these piles, comparing them over and over. It starts to notice hidden connections. It might spot that specific words, like winner, or emails sent from strange web domains, show up almost exclusively in the junk pile. From those observations, the computer builds a logic engine. In computer science, we call this engine the model. It is the set of rules the computer built for itself based on what it saw. When a brand new email arrives in your inbox tomorrow, it gets run through that model. The model checks the message against the patterns it learned and sorts it instantly. The accuracy of that sorting process depends on the quality and the amount of training data it was given in the beginning. But this system has a major flaw. Imagine a student taking a practice exam. Instead of learning the actual math concepts, they just memorize the exact answers. When they sit for the real test, the questions change slightly and they fail completely. In computer science, this is called overfitting. The model accidentally memorized its training data instead of understanding the broad underlying pattern. For example, the spam filter might notice that 3 bad emails in its training set happen to be sent on a Tuesday at 4 p.m. If it overfits, it will assume every single Tuesday afternoon email is junk. This graphic illustrates what happens when those lessons are too specific. The center target shows a model making accurate predictions. But look at the target on the right. Because the model memorized the data too strictly, its predictions are scattered and miss the mark completely. To fix this, programmers put the computer on a complexity diet through a process called regularization. By limiting how intricate the rules can be, they force the machine to ignore the random, hyper-specific details and stick to the big picture. A successful machine learning system has to leave room for variation. Like a good student, it needs to grasp the general pattern without obsessing over the specific examples. That process of extracting patterns from massive piles of data is happening constantly. Streaming platforms feed their models millions of viewing histories. By looking at what similar people watched, the system predicts the movie you'll click next. In the financial sector, banks run models that process thousands of purchasing habits in milliseconds. If your credit card behaves strangely, a model spots the deviation and flags the fraud before the transaction even finishes. In hospitals, models are trained on vast archives of medical scans. They help doctors spot tiny anomalies or early-stage tumors that a human eye might easily overlook. Even the advanced conversational chatbots you use to answer questions or write code are built on this exact same framework of pattern recognition. The artificial intelligence around us is really quite grounded. We simply let computers trade a rigid rulebook for a massive stack of flashcards, allowing them to quietly find the patterns that keep our digital world running.